Good morning everyone. So today we will be discussing about the atoms as well as how these atoms gains electrons and loses electrons and what are the deciding factors which making them to gain electron and lose electron. We will be discussing them. Okay, once after understanding it, we will be having a clear cut view on making compounds or formation of compounds when two elements are combining. Okay, so in the last class I have explained about laws of chemical combination. Right now, like law of conservation of mass and law of constant proportions were discussed in the last class, right? So what this law of conservation of mass says, tell me. So let me explain that in a quick recap manner. See, whenever the two fragments, let us say A and B, are combining to get some product, say something like C and D, then the total mass that you are seeing at the left hand side will be equals to the total mass that is present at the right hand side. For example, here I can write weight of A plus weight of B will be equals to weight of C plus weight of D, we can write. So for better understanding, let us take one chemical reaction. Okay, so here you can say this is methane upon combustion produces carbon dioxide plus water molecule, right now. So now first of all balance the equation. How many carbons you are seeing at this reactant side? See, this side is called, like left hand side is called reactant side, and to this arrow mark, the forward direction here, right hand side can be considered as a product side. Okay, so now how many carbons are at this reactant side? See, there is one carbon, it means product side should also be one carbon. It means what you need to know here is during a chemical reaction the atoms should be conserved. It means number of atoms, that is number of carbon atoms, particular atoms present at reactant side and product side should be same. So one carbon at the reactant side, so product side should also be one carbon. Okay, then after that how many hydrogens are there? 4 hydrogens are there at reactant side, so product side should be also 4. So here only we have 2, so multiply that with one more. Okay, so 2 to the 4 hydrogens are there. Then next thing is, now look at the oxygen atoms. How many are there at the product side? So 2 into 1, there are 2 oxygen atoms here and 2 oxygen atoms here. So total 4 oxygen atoms are there, but here one oxygen molecule is there. In one molecule atomicity here it is 2. So in one molecule 2 oxygen atoms. Like that we require 4 oxygen atoms. So simply multiply this with 2 so that you can make it 4 oxygen atoms. So right, so here if you observe all the atoms are conserved. Okay, so now even if you consider their masses also, for carbon we know it is 12, atomic mass is 12, and for hydrogen each hydrogen will be 1, like that we have 4, so it can be considered as 4. So total here it is 16. And what about these oxygens? See, one oxygen is atomic mass is 16, because how can you consider atomic mass? See, first of all you need to know its atomic number. What is the atomic number of oxygen? 8 now. So atomic number 8 indicates it has 8 protons in it as well as 8 electrons in it. Okay, along with this, for example, if you consider any atom, at the center we have nucleus. In this nucleus we have two things. One is neutrons and other one is proton. So around this nucleus, these circular paths are there now, these are called orbits in which we have electrons. For a particular atom, number of protons and electrons should be equal. Since I am saying oxygen atomic number as 8, it has electrons as 8 as well as protons are also 8. Now what about neutrons? Okay, so up to 20th elements, I mean first 20 element, mostly their atomic number, it means number of protons and neutrons are almost equal, not every time. Okay, so here number of neutrons are also 8, so it can be 60. Now what is the total mass? So whenever they ask about total mass for first 20 elements, you can approximately consider double of its atomic number. So its atomic number is 8, so its mass number becomes 16. Why? Because whenever you are calculating mass number, consider number of protons and number of neutrons. So how many protons are there? 8. How many neutrons are there? 8. So like that mass number becomes 16. Okay, so for one oxygen atom 16. Like that how many are there? 4 are there. 4 oxygen atoms are there, each one 16. So this will be 64. So the total sum here will be 64 plus 16 will be 80, right now. So total mass at the reactant side will be 80. Now look at the product side. So there is carbon dioxide. For each carbon, atomic number is 6, so mass number will be 12. Okay, and there are 2 oxygen atoms, each one will be 16, so 32 plus 12, so 44 for carbon dioxide. So similarly, if you do it for water molecule, there are 2 water molecules, each water molecule weight will be 18. So if you want, you can consider hydrogen as 1 into 2, oxygen as 16, so 2 plus 16, 18, like that you can write. So total will be 36. So sum of these two numbers will be again equals to 80. Okay, it means what you have observed during a chemical reaction, the total mass present at the reactant side and total mass present at the product side will be equal. So this is called a law of conservation of mass. Okay, and in the last class I told you law of conservation of mass is not applicable in case of radioactive reactions. In which reactions? Radioactive reactions or nuclear reactions, as well as when there is non-stoichiometric reactants. Okay, non-stoichiometric reactants. Okay, so non-stoichiometric means like generally you can say interstitial compounds. Okay, and radioactive reactions. Why radioactive reactions they won't obey law of conservation of mass? Because during a chemical reaction, nuclear chemical reaction, what happens? Some of the mass will be converted into energy. So since mass is converting into energy, the total mass cannot be conserved. Okay, so that's why law of conservation is not applicable in case of radioactive reactions as well as non-stoichiometric or interstitial compounds case. Okay, remember these 2 points. Done. Okay, then next thing today let us understand about this periodic table. Okay, so you can take any of this periodic table. I have got 2 things here. You can take any of this. Okay. So here, if you observe this periodic table, so periodic table presently we have 118 elements. How many elements are there? 118 elements. Okay. So now these 118 elements are arranged in such a way that studying their properties should be like simpler and easy to remember. Like that they have arranged. It means periodic table is now classified as 4 blocks. How many blocks? 4 blocks. So these first 2 lines are there now, these 2. Let me change the color. So these 2 are there now, so these are called S block. What is that? S block. Okay, and now here you are seeing now from boron to helium, I mean this thing. So this thing is called now P block. Okay, so in between S and P we have this as D block. D block. And within the D block, if you observe, there is a lanthanum with this particular color. So at the place of lanthanum only, these all elements should be placed. Okay, and at the place of actinum, this all elements should be placed. It means this bottom group is there, this bottom 2 lines are there now. So these are called F block elements. What we can call F block elements. So the first series is called lanthanides and second series is called actinides. Okay, remember like this. Okay, now one more thing. Here if you observe from this, you can consider this as the left hand side, from left, this is left side and this is right side if you consider. So as we move from left to right, what happens to the properties they will ask. Okay, so generally in order to understand something related to oxidation state, I just want to discuss metallic nature, non-metallic nature, only these 2 things for today's class. Okay, see, all the S block elements are metals. What I am saying, all the S block elements are metals. Okay, so as we move from S block to P block, what happens is that metallic nature decreases. It means we have non-metals in the P block elements. So all these halogens you are seeing now, so what are these? All these are non-metals. Okay, so what I am saying, metals, non-metal. Sir, how can we define metallic nature or how can we identify a metal? Yeah, it is very simple. So metal, when you are making some reaction with a particular metal, it try to lose its electron. So whenever you do a chemical reaction with any of these metals, any chemical reaction you can do with these elements, they try to lose their electrons. It means you take a sodium metal, like metal piece, you take sodium metal piece, you just expose it to the moisture like air, or you just throw in the water. What happens is, when you are throwing in the water, you are going to see a huge exothermic reaction. You are going to see the fire also that time. Okay, why? Because this sodium loses electron, that electron is taken by this H plus from the water and liberates H2 gas. Which gas it will be liberating? H2 gas. Okay, now sodium is losing electron means, see, whenever an element loses electrons, see, if an A is an element, if it is losing an electron, so it becomes A plus, so it will converts into a cationic form when it is releasing an electron. Remember this. Okay, whenever an element accepts an electron, see, if A is an element accepting one electron, so what happens means it becomes A minus. So losing the electron becomes A plus, gaining the electron becomes A minus. So this A plus is called cation. Okay, when an electron is lost by an atom, becomes cation. When it gains an electron, becomes anion. Remember this terminology, very important terminology that we are going to use them. Okay, so now what happens? Sodium losing electron, it becomes sodium plus. It means it becomes a cation. Okay, sodium cation you can say. So now from this, H plus is converted into H2 and remaining OH convert, like it will be like this, NaOH. So formation of NaOH takes place along with the liberation of H2 gas when sodium thrown in the water. Okay, like that, any of the element you take, whenever any of the element, this S block elements you take from lithium to francium, they are going to release the electron and converts into respective unipositive charges like sodium cation, potassium cation, rubidium cation, like that. And now one more thing, sir, what happens to reactivity as we move down the group? See, I am moving from sodium to, now I am moving from sodium to potassium, potassium to rubidium, rubidium to cesium. As we move down the group, that reactive nature increases. It means who is losing the electron easily? Cesium loses electron easily. Now what I told you, when you throw the sodium metal in the water, you are going to see an exothermic reaction by releasing the fire. I told you now that exothermic nature increases as we move down the group. It means huge amount of heat is released when you are throwing cesium in the water. Okay, so don't throw that. Just I am saying for understanding purpose. Okay, because we are going to see a huge amount of fire if you throw in the water. Okay, so now what happens, what does it indicates? As we move down the group, that metallic nature increases. Metallic nature increasing, how I can say? That element wants to be in the unipositive charge or with a positive charge in the cationic form only. So metals are electropositive. More electropositive nature, more is the metallic nature. Once again, more is the electropositive character, more is the metallic nature. Okay, so all of them are metals, but metallic nature increases down the group. So which is having more metallic nature here? Cesium, next rubidium, next potassium, least is sodium. Once again, all of them are metals, but metallic nature increases down the group. Because why? It depends on the tendency to lose the electron, the tendency to be in the positive charge will be more for cesium. అర్థమైంది అనుకుంటా. సో యాజ్ వి మూవ్ డౌన్ ద గ్రూప్ ఏమవుతుంది, ఆ ఎలక్ట్రాన్ని లూజ్ అయ్యే స్వభావం పెరుగుతుంది. సో దట్ దే వాంటెడ్ టు బి ఇన్ ద పాజిటివ్ చార్జ్. సో మోర్ ఎలక్ట్రోపాజిటివ్ నేచర్, మోర్ ఇస్ ద electropositivity, metallic nature. Remember like that. So now when you take this side elements like p block elements, so here let us consider halogens. So halogens like fluorine, chlorine, bromine, iodine if you consider. So how they will be? These are non-metals I am saying. So what I am saying? Non-metals. So non-metals, what these non-metals will do is, they wanted to gain the electron. So non-metals are electronegative. So what I am saying, metals are electropositive, non-metals are electronegative. So electronegative means they wanted to be in the negatively charged state. It means fluorine upon treating with something, what I am saying, fluorine upon treating with something, the fluorine always wanted to be with a -1 charge. What is the charge on it? -1. For example, you are treating fluorine with oxygen, oxygen or any other thing, you can treat with water here, as we treated here with water, here also you can take with water. So you are going to get a F minus charge there, or you are treating them with something like magnesium or any other metals. Now what happens here, magnesium is a metal, loses electron, that last electrons are taken by the fluorine and becomes magnesium fluoride, something like this. See why I have written MgF2 times, because here magnesium belongs to which group you are seeing? Magnesium belongs to second group now. So in the valency of these second group elements, valency electrons are 2. So all these 2 electrons are lost by these metals, like this second group elements, that will be taken by the reacting species. So who is reacting here? Fluorine is reacting now. So fluorine, upon treating with magnesium, you are going to see something like MgF2. Okay. So if I only treat sodium with fluorine, what happens? So 2 sodiums we required. Why? Because each sodium loses 1 electron and becomes Na plus. Okay, like that last electron is taken by 1 fluorine and becomes F minus. Like that, how many fluorines are there? It is 2, because halogens will be in the diatomic state, not in the monoatomic form. Okay, so how these non-metals exist? In the diatomic form, like F2, Cl2, Br2, like that. So this diatomic I am saying now, so that number is called atomicity of that particular element. So what is the atomicity of fluorine here? 2. Okay. So whereas sodium, like these metals we are seeing, they will be in the atomic state only, like elemental, like sodium, metal, atom, you can write like this. So 2 sodium loses 2 electrons that are taken by fluorine and becomes Na plus F minus. Like that, how many it will be forming? 2 it will be forming. So you can write like this. So even with the fluorine also, chlorine also, everything the same reaction. Okay, similar reaction. Okay, so now for an element, so I'm giving one more hint here. For an element, if there is no charge on it, it means 0 charge. That 0 charge is called its oxidation state. So every element without any charge or in its atomic form, oxidation state will be 0. If that element is losing the electron, becomes positive charge now. So now whatever the charge present on that ion is called its oxidation state. Now what is the, like how much positive charge you are seeing? +1 now. So that is the oxidation state of sodium. So what is the oxidation state of sodium here? It will be +1. Okay. Now let us generalize this by taking an element A as an example. So this A element is in atomic form now, so there is no charge. So oxidation state here will be 0. Now if this A element losing 1 electron, so -1 means it is losing -1 electron, it is losing. So if it is losing 1 electron, you should write it as A plus. If it is losing 2 electrons, you should write it as A2 plus. If it is losing 3 electrons, you should write it as A3 plus. Like this you need to write. So atom after losing electron becomes ion. Which ion? Cation. So all these are what? Cations. Okay. Now in the cationic state, for element existing in the cationic form, whatever the charge present on it will be its oxidation state. So now what is the oxidation states here? You are seeing +1, here it is +2, here it is +3. So if it is losing some n number of electrons, then the oxidation state will be +n. So the oxidation state becomes +n. If it is losing 4 electrons, it becomes +4. Like that you can understand. Okay. Now here, if the element gaining the electrons, let us say 1 electron is added to this element. Now what happens? It becomes A minus 1. Okay. So I am adding 2 electrons. So it becomes A minus 2. I am adding 3 electrons, A minus 3. Like this if you keep on adding. So now what happens? They are becoming negative charges, right? Now atom converting into ionic form. Which ionic form? Anionic form. Okay. Negative charge, anion. Positive charge, cation. So whatever the charge present on these ions are their oxidation state. So in this case, what is the oxidation state? You can say oxidation state will be -1. Here it will be -2. Here it will be -3. Okay, that's it. I hope up to here it is clear. Okay. Now let us consider few examples. Here. I have written it as sodium chloride. Right now, sodium chloride. Now, who is losing the electron when we are getting a compound like this? So sodium loses electron, I told you, therefore it will be in the positive charge. Okay, that last electron gained by this non-metal chlorine, so it becomes Cl minus. Okay, now what is the charge present on the sodium? It is plus 1 now, so its oxidation state will be plus 1. So what is the charge here? We are writing minus 1. So oxidation state of chlorine is minus. Okay, now whenever you are writing chlorine like this, you should simply say chlorine atom, chlorine molecule, or just chlorine. When you are writing Cl with minus charge, you should call it as chloride ion. What is that? Chloride ion. Chloride ion. Okay, I hope it is clear. Simply in the exam, if they mention chlorine, so chlorine means what is the standard state of chlorine? Molecular form. So this is chlorine. Only if they mention it as chlorine atom, consider its atomic form. Same story applicable for oxygen, nitrogen also. Because in the exam they will ask you something like this. What is a, by giving you a question like this. 14 grams of nitrogen is present or given, then number of moles of nitrogen will be, they will ask number of moles of nitrogen will be. So how can you understand this question? See, they mention nitrogen now, they haven't given a clarity whether atom or molecule. So what you need to understand, nitrogen's standard state, nitrogen will be in the diatomic form now, so you should consider it as a molecule, not as an atom. Okay, only if they mention it as nitrogen atom, consider as single element like nitrogen atom. They simply mention the term nitrogen, take it as N2. Same story applicable for hydrogen, oxygen, all these elements. Okay, right. Okay, now look at this. So all alkali metals in the periodic table, if you observe, all these elements if you observe in the periodic table will be with a plus 1 charge. Okay, so just remove hydrogen from here. We are not discussing about hydrogen here. Mostly for all other elements I am discussing. Okay, even hydrogen also with plus 1 charge, but sometimes it will be even minus 1 charge also. So voice is can't able to hear. I think it is clear only. Okay, let's move forward. Okay, then next here if you observe, all these elements which are in the second group here, these vertical lines, see, remember in the periodic table we use some basic terminology. This is called a vertical line and this is horizontal. I hope you know this. So these vertical lines are called groups. What we can call? These are as groups. Okay, and here horizontal lines are called periods. Okay, you can write in the short forms. Okay, groups and periods. Like that, if you observe in complete periodic table, there are 18 vertical columns. How many vertical columns you are seeing? 18 vertical columns are there. All of them are considered as groups. Okay, and if you observe like this, horizontal rows are called periods. And how many of them? 7 periods, 18 groups. Okay, this is the story. Now remember, all the lanthanides, what I am saying, all the lanthanides will be at this position I am saying now. So this position means which period it is? 6th period. So all lanthanides should be present in the 6th period. Okay, in which period? 6th period. Okay, now what about actinides? All actinides should be this down series, should be at this position. It means along with the 89, all these elements should be placed. So all actinides are lies in which group? So this will be in the 7th period. Here lanthanides are in 6th period, actinides are in 7th period, and which group they are? In the 3rd group of the periodic table. In the which group? 3rd group of the periodic table, you can remember. Okay, all of them are lies in the only single group, and which group it is? Particularly you can say it's the 3rd group. Okay, remember this. Okay, now up to here S block elements, I hope you got some clarity. So all the S block elements, first group elements will be with +1 charge, and second group elements will be with +2 charges when they combined with something. Okay, it means something means what? So magnesium upon treating with oxygen, so what you are going to get? So you are going to get magnesium oxide. So what will be the oxidation state here? So magnesium loses 2 electrons that are taken by the oxygen and converts Mg +2 O -2. So net charge is how much? +2 - 2 means 0 na? So that's why we are not writing any charge on the molecule or the compound here. Okay, that's it. Okay, now 0 is converting into +2 charge. Okay, and here 0 is converting into -2 charge for the oxygen. So for that, how many magnesiums required? 2. Okay, therefore you are going to get 2 MgO. So this is the balanced equation. Okay, right. The next one, when it comes to boron family, so they will be with the +3 charge. How much oxidation state? +3 charge. For example, there is aluminium reacting with like oxygen, or you can consider any halogens like chlorine. So what happens is, first you write aluminium as Al +3. Okay, you write it as Al +3. So in order to make this +3 charge, how many oxygens required or how many chlorines required? So in order to make Al +3 charge, each chlorine will be with -1 charge, so that will be -1. Okay, so now you do a crisscross method, this charge over here, this charge over here, so it becomes Al3 Al, this charge over here na crisscross means 1. Okay, and this one is here, so Cl3, so AlCl3 will be the formula of this compound. Okay, so same like that, aluminum will be with +3 charge, oxygen will be with -2 charge. So why I am writing say -2, why you are writing +3 means, you just observe oxygen in the periodic table, if you take where it is here. So oxygen is at here and its atomic number is like 8, and it required 2 more electrons to become like a neon. Okay, so you just remember, in periodic table all the elements shows chemical reactions to attain a stable state, that is inert gas configuration. So every chemical reaction happens to gain the stability. Okay, so this means oxygen is at here, that required 2 more electrons to become like a neon. Okay, that's why oxygen try to gain 2 electrons all the time. So by gaining 2 electrons, oxygen will be with -2 charge. Oxygen will be with -2 charge. Oxygen converting into O -2. Why? Here only 8 electrons are there. By giving the 2 electrons, become a neon gas configuration, which is a noble gas. All these elements are stable, you can consider. Okay, you just consider for understanding purpose. All noble gases are highly stable, therefore the remaining elements try to gain the configuration as like the noble gases. By gaining 2 electrons or by losing some electrons, they wanted to become like this. See, sir, why you are saying sodium loses 1 electron means, see, atomic number of sodium is 11. By losing 1 electron, it becomes a sodium plus charge. How much charge? plus charge. See, by losing one electron, so 11 electrons are there initially, by losing one electron it becomes a 10 electron now. How many electrons are there? So 10 electrons. So 10 electrons means which element? It is a neon gas configuration. So that's why all alkali metals loses one electron. It means that first line of the series. Okay, and second line if we take like beryllium, magnesium, calcium, so they wanted to lose 2 electrons so that they becomes like noble gas configuration. Magnesium atomic number is 12, by losing 2 electrons it becomes 10 electron system like neon. Okay, they are stable. Okay, like that. So whereas aluminium atomic number is 13, so by losing this last 3 electrons, aluminium also become like a neon. Okay, whereas if you observe oxygen, sulfur, what happens? They are very close to the nearest noble gas. See, what is the nearest noble gas we have for sulfur? Argon. Na? So 16 can become 18 by gaining 2 electrons. So you give 2 electrons to sulfur, it becomes S minus 2. It becomes S minus 2, which is a argon gas configuration. So what you can understand from this? Elements try to attain the stability by losing the electrons or by gaining the electrons. Okay. Now during this process, whatever the net charge present on that element or the ion is called its oxidation state. Okay. So now sulfur in atomic form there is no charge on it. So here oxidation state is 0. Now by gaining 2 electrons it is becoming minus 2 now. So what is the oxidation state? You should say minus 2 for the sulfur. Okay. Whereas halogens, if you observe, they are just required 1 electron to become a noble gas configuration like this. All halogens if you observe. So that's why they always try converting from 0 from here to minus 1 state. So all the time when you are writing halogens with some other less electronegative atoms, write minus 1 charge on that halogen. Okay, right. Okay, so here aluminium by losing 3 electrons becomes plus 3, oxygen by gaining 2 electrons becomes minus 2. So now what I told you, do that crisscross method. Crisscross method means what? So these 3 at here, these 2 at here. So you can simply write Al2O3 like this, Al2O3. Okay, next thing, I can give you some other examples now. Tell me, calcium treated with chlorine. So what type of compound you are expecting here? Very simple, na? So do the crisscross method and you can do. So calcium, which group element this is again? Second group element now. So what are the elements we have? Beryllium, magnesium, calcium. Okay, so like this. So how can I remember these elements? I will give you a trick. So second group elements, you just remember that as like this. BMC, SBR. All the elements are done. BMC, SBR. So beryllium B, magnesium Mg, calcium Ca, the next strontium Sr, barium Ba, radium Ra, like this. So what is the code word I given you for the second group elements? BMC, SBR. You can remember. So all these elements are with what charge? Plus 2 charge. Okay. So now down the group, the elements with plus 2 charge, it means metallic nature increases now. So that plus 2 charge will be more stable at the down the group. It means bottom elements you can remember like that. Okay. So by losing 2 electrons, calcium atom becomes calcium plus 2 ion. Okay. That last electrons are taken by each of the chlorine because chlorines required 1 electron now. So 2 chlorine atoms becomes 2 chloride ions. Okay. So 2 chloride ions. Okay. Now what I told you, do this crisscross method I told you. So what is that? So this charge over here and this charge over here. So what happens? CaCl2. So this is how you need to make a molecular formula. Okay. I hope it is clear. There is no confusion, right? Yeah. Yeah. So let's move forward. Okay. Next. One more thing. I just wanted to remind you the same thing from the last class. See, an element is indicated with symbol chi, let us say. An element is represented like this, and what you are going to write here, here it is going to be its atomic number, and here it is going to be its mass number. Okay, and here it is going to be a charge. What is a charge? Like some are with positive charges, negative charges, something like that. Now you can write here, and this position is to indicate atomicity. Okay, in the last class also I have discussed. For example, carbon with atomic number 6, mass number 12, okay, and if I write element, there is no charge, so don't put anything on it. Okay, atomic form. So its atomicity is only 1, so it will be like this. So atomicity 1 means you can write 1 or no need of writing also. By default, if there is nothing, means you can understand it as a 1. Okay, whereas nitrogen won't be in the atomic form, it will be in the molecular state, like a nitrogen gas. So therefore you are going to get the number 2 here. Okay, and what is its atomic number? Generally we can say 7. Okay, and mass number if you consider like 14. Okay, if there is any charge here, you mention. If any atomicity is there, you can write here. Okay, generally nitrogen gaining 3 electrons, because nitrogen is a group 15 element now. So in order to become 18th group, that noble gas configuration, it gains 3 electrons. So by gaining 3 electrons, it becomes N3 minus. Okay, and mass number remains the same, atomic number also remains the same like this. So you can write in this manner. Okay, guys, is this clear or not, or any confusions are there? Okay, so if there is any confusion, please write in the chat box. So now there are some examples to be understood here. Whenever you are writing an element like this, C6, 12 I have written. So what is this 6 indicates and 12 indicates? Let us understand that story. So 6 indicates what? Number of protons, that is nothing but its atomic number. Okay, so atomic number and number of electrons should be same, 6 and 6. Okay, then next, here 12 is there now, so this 12 is indicates mass number I told you. So how can you write a mass number? So mass number is indicated with symbol A, which is equals to number of protons plus number of neutrons in it. Okay, so for a particular element, its atomic number equals to its number of protons in it. So 6 for carbon. Okay, neutrons will be either equal to atomic number or may be greater than atomic number or less than atomic number also. Okay, by 1 unit. So here I am taking them as equal. Okay, it means I can show you the different things here. See, 3 things I have written, all of them are carbons only with atomic number 6, 6, 6. But here I am writing it as 12, writing here 13, 14. So what makes the difference between them? All of them are carbon atoms, but mass number is 12, mass number is 13, and here it is 14. So these are called isotopes of carbon. What they are? Isotopes of carbon. So how the isotopes are differ? Atoms or elements with species with the same atomic number but different mass number are called isotopes. So why that mass numbers are different here? Because the number of neutrons are different in these 3 cases. Because protons are same but number of neutrons are different. Okay, here what I told you, mass number equals to protons plus neutrons. So now 12, how we got this 12? So 6 protons and 6 neutrons in this atom. That's why we are writing it as 12. And in this case, I am writing it as 13. But it has only 6 protons. Means number of neutrons are 7. Okay, here it is 6, here it is 7. And the last one, if you observe, mass number is 14, but atomic number of protons are 6 only. So neutrons will be how many? 14 minus 6. So I am asking neutrons means mass number minus proton number. So mass number A minus P, if you do, you will get N, number of neutrons. So mass number is 14 minus 6, you will get 8. Okay, so if you see these 3 things, they are varying in their number of neutrons. Okay, so like that you can count. Anyways, I have mentioned a table here, make a note of this table. Okay, the next thing, here I have represented an element like this. Nitrogen I have represented with number 7 and charge with minus 3. So what does it says? What does it says? Try to understand these things first. Okay, then later slowly we'll understand the concept of oxidation state clearly. So this 7 and charge says that its atomic number is atomic number is 7. It means number of protons are 7. Okay, next. If there is no indication of mass number, consider it as stable isotope. What is a stable or most naturally abundant isotope of nitrogen? It is 14 isotope, right now. So its mass number is 14. So if its mass number is 14, so mass number, that is atomic mass number. So A indicates what? Mass number. You can write in the bracket here. Mass number is given as how much? 14. So mass number A will be equals to number of neutrons plus protons, I told you. So now what happens to the number of neutron count? Number of neutrons N will be equals to A minus P. A minus P, that P is nothing but its atomic number. So A is 14 minus P, protons are 7. So mass number, neutron number is also 7. Now what about total electron count in it? Total electron count. Electron count. How many electrons are there in the given species? So whenever I write like this, so 7 indicates its atomic number. So an atom has same number of protons and same number of electrons, that is equals to 7. But if you are writing any charges over here, so that charge indicates loss of electrons or gain of electron. If it is a negative charge, gain of electron. Positive charge, loss of electron. So it is negative charge now. It means this nitrogen atom gained 3 electrons, that's why it is minus 3. Initially in the atom it has 7 electrons and total charge it is having minus 3 on it. So total electron count will be 10 electrons. Okay, I hope this is clear. Now look at the table once again. Look at the table. So what this table is indicating here? So sulfur with base 16 and upper here it is 32 and with charge minus 2. So what it is indicating? Atomic number protons will be 16, okay, and the mass number, what I told you, mass number here 32. So from that, how can you get number of neutrons? Mass number minus number of protons gives you neutron number. Okay, mass number is 32, proton count is 16, so neutrons are also 16 now. Okay, like that you can write neutrons. Then next, what about its electron count? So its atomic number plus what is the charge present on it. If minus 2 charge is there, like minus charge is there, add that many electrons. Plus charge is there, remove that many electrons. So here minus 2 means add 2 electrons to it. So total how many electrons it is becoming? 18 electrons. That's why you have written here 18. Like that you can make some more clarity from these 2 examples. Okay, hope this discussion is clear up to here. Right, let's discuss few more things. Okay. Now in the exam questions will be like this. So this is a NEET 2024 question. Just observe what they are saying. Arrange the following elements in the increasing order of electronegativity. See, today we haven't discussed about electronegativity, but we discussed about electropositivity to some extent and little extent of electronegativity when we are studying about p block elements, right? So now what I told you, as we move from left hand side to right hand side, we have non-metals here. These non-metals are electronegative elements, I told you. Okay, so as per that, if you observe these elements, which group will be at the end of the table? End of the table. Fluorine will be at the end of the table now. So it means this is more electronegative atom. So after this oxygen, okay, after this nitrogen. So how can I understand this means? You just consider any of this table, any of the periodic table that I have shown you. Where is the table? You consider any of the table. So which is at the right hand side of the table? Fluorine now. So fluorine is at the right hand side. Don't consider noble gases. These are stable and inert. They won't show reactivity. So fluorine is at the right hand side. So this is most electronegative element. So first most electronegative element in the periodic table is what? Fluorine. And second most electronegative element in the periodic table is oxygen. Now what about third most electronegative element? Yeah, here we have nitrogen, here we have chlorine. So what you can understand is that electronegativity nature decreases as we move down the group and electropositive nature increases as we move down the group. So here chlorine is less electronegative than fluorine, then it is bromine is lesser electronegative and this is little more lesser. Like that as we go down the group, electronegativity nature decreases. So here you can remember nitrogen and chlorine are having almost equal electronegative values. Then after that chlorine, carbon we have like that. Okay. So based on this you can answer the question. So what I told you, fluorine, oxygen, nitrogen, fluorine, oxygen, nitrogen. Like that, do we have any other option? No. So only this is there now, you can go with the second option. Okay. How simply you can solve this question, see. Okay. So now what I tell you is, you again go through the periodic table classification of element from your class 10th book. So just grind the chapter very effectively, and if you have any doubts, you please mention in the chat box. We will be discussing them in the upcoming session. So what are the 3 chapters I am giving you now? So one is periodic table and classification. Okay, second chapter will be your structure of atom, and the third chapter will be something related to chemical bonding. Okay, you study these 3 chapters clearly. Okay, these 3 concepts also, so that you can get some clarity over our discussion. Any doubts are there, feel free to express in the chat box, or you can join our WhatsApp group from the mobile number provided in the description, or there you can mention our Telegram group, that link, whatever the things mentioned in the group, description, join there, share your doubts, we can discuss there itself, or in the next upcoming sessions we will be covering them. So thanks for watching, stay connected with NEET World channel. Thank you.